Determine the missing properties and the phase for water in each of the following states. For each case, we have only two properties. As discussed before, the state of a thermodynamic system can be defined by only two independent variables, and all other variables can be determined from those two. We'll demonstrate this in these examples. In example 1, the quality is given to be x equals 0.8. This means that we have saturated liquid-vapor mixture at a temperature of 150 degrees Celsius. Therefore, the pressure must be the saturation pressure at this given temperature. Using the temperature table for saturated water, we find the saturation pressure to be 476.16 kilopascals. Using the same table, we can read the enthalpy for saturated liquid, HF, and saturated liquid vapor difference, HFG, at this temperature. Using these values and quality, we can calculate the enthalpy from its corresponding equation. In example 2, temperature and pressure are given, but we do not know which table to use to determine the missing properties, because we have no information about material's phase. To determine the phase, we first look at the saturation pressure at the given temperature. We found this from previous example to be 476.16 kilopascals. Since the material's pressure, 300 kilopascals, is smaller than the saturation pressure, we are in the superheated vapor region. So we need to use the superheated vapor table for water. At temperature of 150 degrees Celsius and pressure of 300 kilopascals, which is 0.3 megapascals, the enthalpy is 2,761.2 kilojoules per kilogram. In example 3, we have temperature and pressure, but again, we do not know which table to use. Using the saturation pressure at the given temperature that we determined earlier, we see that the material's pressure, 600 kilopascals, is higher than the saturation pressure. Therefore, we are in the compressed liquid region. The compressed liquid tables for water start at 5 megapascals, so we can't use the table. As discussed earlier in this lesson, in the absence of compressed liquid data, a general approximation is to treat compressed liquid as a saturated liquid at the given temperature. Therefore, the enthalpy is approximated as the enthalpy of liquid water at 150 degrees Celsius, which we found in example 1 from saturation table to be 632.18 kilojoules per kilogram. Since these three examples are related, it is useful to summarize their answers in this table. We can also locate the thermodynamic state of each example on the phase diagram. Example 1 is in the saturated liquid-vapor mixture region at a pressure of 476 kilopascals and a temperature of 150 degrees Celsius. Example 2 is in the superheated vapor region at a lower pressure of 300 kilopascals, but the same temperature of 150 degrees Celsius. And finally, example 3 is in the compressed liquid region at a higher pressure of 600 kilopascals and the same temperature.